Let's try one last problem. We've got negative 2y minus 3x squared equals 2. Let's solve this for y. To solve this thing for y, what we'll do is, first of all, let's move that 3x squared term. So, well, it's negative, so let's go ahead and do the opposite. We'll add 3x squared to both sides. And that will give us negative 2y equals 3x squared plus 2. Next thing that we'll do is we'll divide both sides, everything on both sides, by a negative 2. Let's see what that gets us. That gets us a y equals negative 3 halves x squared, because you had to divide the 3 by the negative 2. But you also have to divide the 2 by a negative 2, which will give you a negative 1. Almost done. The last thing is, we've got the y by itself. We just need to give it the fancier notation instead. So replace the y with the f of x instead, and leave everything else the same. So we'll leave it as negative 3 halves x squared minus 1, and that's our function notation. We're done. This last thing that we want to do is actually graph lines. Well, we've already done that. We did it mostly in the form y equals mx plus b. Now we're going to do the same thing. It'll look different because instead of a y, we'll have an f of x, but it isn't any different than anything we've done before. So we'll be looking at f of x instead of y equals mx plus b. But we're going to graph it the same way, which, how did we do this before? We started out with the b first, which was so we started out with the b. We start with b, which was your y-intercept, where you intersect the y-axis. Then we moved on to using the m, which was the slope. The slope gave us a map on how to get from our B to a new point, a second point, so that we could draw our line. We used it as rise over run, where the rise told us if we were going up or down based on if it was positive or negative, and the run told us whether or not we were going left or right based on if it was positive or negative. So this should be nothing new. So let's look at this. This first one, we've got f of x equals 2x minus 1. So the first thing that we would actually start out with is the negative 1, which is where we're going to intersect the y-axis down at negative 1. After that, then we want to go after our slope, which is going to tell us how to get to a second point. Well, our slope, which is 2, well, the question is, what's on the bottom? Well, what's on the bottom, if we can't see anything, is a hidden 1. And this is a positive slope, so that means we're going to go up 2 and right 1 from our y-intercept. So we'll go up 2 and then right 1, and that's where my second point will be. Then all I need to do is draw my line through my 2 points, and I am done. It's nothing new. The only thing we want to add on is our domain and our range. Remember, domain has to deal with x values in reading your graph from left to right. But notice, lines go forever from left to right. So our domain will just be negative infinity to positive infinity. What about our range, though? Our range, our y values. Let's look at our y-axis. Again, remember we read from the bottom, from down at the bottom at negative infinity, and read our way all the way to the top. Work our way from smallest to largest. And notice our graph goes down forever and up forever. So our range is going to also be negative infinity to infinity. We talked about this in the last section, in section 2.5, that the domain and range of almost all lines would both be negative infinity to infinity. So this is a good reminder. It's all matching up now. Let's take a look at B. On B, we're going to again start with the y-intercept, which is positive 2. So we'll start there, which means that's where we're going to intersect. The y-axis is at positive 2. Then we can use our slope, the negative 1/2, to come up with a map on how to get from our first point to the second. Remember when we did lines before is you need to use the negative once. You can either use it as part of the rise or part of the run, but not both. I'm going to use it as a part of my rise so that it's going to tell me that I'm going to go down 1, but then that makes my run positive 2, so I'll go right 2. So I'm going to go down 1 and right 2 for my second point. And then I can just draw my line through my 2 points, and I am done. Just like the last one, let's notice that our domain here, reading our graph from left to right, from negative infinity to positive infinity, goes to the left and to the right forever. So our domain will be negative infinity to positive infinity. And with regards to the range, let's see. For the range, we're going to have, reading it from smallest down at negative infinity, working our way up to positive infinity, is that it goes down forever and up forever. So again, it will be negative infinity to positive infinity. And notice this is still true. The domain and range of almost every single line is going to be negative infinity to infinity, unless it's one of our 2 special cases. We had 2 special cases with lines, horizontals and verticals. So let's take a look at this next one. Well, the reason why we know this is one of our 2 special cases is because we've only got a number. So the question is it the horizontal, or is it the vux? So is it vux or hoi? Well, and if you're not sure, you have to go back and remember f of x, we just talked about this a second ago, is the same thing as a y. So I can replace the f of x with a y equals instead and leave the 2 alone. Well, remember that which one has the y in it is the hoi. So we're looking at a horizontal line where at, let's see, we're looking at a horizontal line at 2. So let's go ahead and draw our horizontal line at, here's 2. So I'm going to draw my horizontal line there at 2. Now let's talk about our domain first. Our domain, again, as a reminder, has to deal with reading our graph from left to right, from smallest to largest. Notice our graph still goes forever left and right, so it'll still be negative infinity to infinity for our domain. However, our range is a little bit different. Why is our range different? Well, if we look at the y-axis just a little bit, notice that there's no graph going down forever. There's no graph going up forever. Actually, there's only a graph here right in the middle here at, and it's only here at this value in the middle here at 2. And that makes sense. By saying y equals 2, we talked about this before, it doesn't matter what x equals. You can have infinitely many options here, but the y is always going to be 2. So the only thing you're going to get out as a range for your y values is just the number 2. Now, how do I make sure I only include the number 2 and nothing else? This is what we talked about in the last section, in section 2.5. When you just want to list a few specific values, or in this case, just one number, remember that we just use braces. So what this means is the only number you'll ever get out as part of your range in a y value is the number 2. When is this only going to happen for function notation? It's only going to happen when you have an f of x equal to just a number, because y's and f of x are the same thing. It will be a Hoy case. Notice it won't ever be a Vux case, because f of x always means y. It never means x.